Okay, we are officially recording. ME304, Mechanics of Material, Fall 2020. So this is my name. This is my name, and this is my email address. In these days, some people send the email to my grader. This is my TA or grader. So if you have any question, first of all, send the email to me. But if you have any, after the grading the homework, if you have question, then you can send the email to my grader. But if you have any general question or anything, you can just directly send the email to me. That's my email address. This is the class, and so this course is the Mechanics of the Material is one of the important courses for the mechanical engineering, aerospace, civil engineering. That's very important classes. And the prerequisite for this course is the ME200. It's the proof of prerequisites. Because I don't need the proof. I will check from the system. If some people, if there is some issue for people, then I will directly contact them. But one time I checked the system, most of you just pass the prerequisites, no worry. But if, for example, some people transfer from the some college and there is a problem, I just ask them. So, okay, you have a question, just ask me. If you...
Yeah, I was just wondering how to pronounce your last name. Is it Packraven?
Yes, it's good.
Okay, perfect. Thank you, Professor.
Sure. So yeah, so no worry for prerequisites. I want to check the web portal once again. If some issue, then I maybe directly contact you. So in this class, let's talk about the material. So let me ask a question. Have you already taken or have you already passed the mechanics of lab, material lab, or something like that? Material lab or...
I'm actually enrolled in it right now, so.
Okay, that's funny. So we don't have...
Yeah, same.
Okay, yeah, we don't need much more. If you already passed, maybe you have a little background about the stress strain curve or something like that. Otherwise, no worry, just we cover everything here. So there is something chat. Okay, that's fine. Because last semester, yeah, some people pass, some people taking, so no worry. So we're going to talk about the. So there is one major difference between this course and the other course. So for many courses, for example, statics and dynamic, the course started from maybe some easier stuff, and then the material will be more difficult and complicated. But the problem for this class is totally inverse. At the beginning of the semester, we have the topic is very dense. The topic maybe is very, very new for you. It's very difficult maybe to get the concept. But after some lectures, all the concepts would be the constants. So then some problem would be changed. For example, the concept would be the same, but the problem maybe instead of flexure goes to torsion, instead of maybe actual go to something else. So, but the initial concept, we're going to talk about the stress at the beginning, is very, very important. And so maybe, yeah, the more loading of this course, it happens at the beginning. Then if at the beginning of the semester you got all the points, then for the rest of the semester, maybe it would be good for you. Then the other things, so yeah, these are some topics, these are some general outcomes, SLO, student learning outcomes. And based on this outcome, so we're going to focus on this textbook. This is a very, very, very famous textbook, Mechanics of the Material, Beer Johnson. However, any Mechanics of the Material, the initial chapters would be the same. I want to focus on the 8 editions, but if you already have edition 7, 6, 5, that's fine. The material would be exactly the same. The only difference for the homework problems, So, but so since I assigned the homework based on the 8 editions, I will scan the that pages and also post in the Blackboard if somebody used the older editions just for doing the homework. So we should be use the 8 editions, right? But if you already have the 8 edition, that's fine. Just look at the numbers, and again you can buy, rent, use book, maybe electronic version, anything that's fine. And this semester we don't want to use the Connect. We don't want to use the Connect, and there is a reason for that. And the reason is, let me ask the questions. You're using your cam. No cam. Do you want? Let me. Okay, let me. Okay.
Yeah, I was just wondering if you're linking up the camera or not, so we get to see
Can
what
you
the
see
prompt
me
looks
now?
like.
If it's
Yup.
easier.
There you are.
We can see, yeah.
Okay.
There's the boss.
Okay. Yeah. Okay. That's fine. So yeah, usually I turn off the camera, but that's fine. Okay. So okay, for this semester we will not use the online assignment, and there is a problem for that because because the department want to get the ABET, that's standards, and to do that we need some handwriting homework from the students, maybe some sample of the handwriting. The problems for online assignments, the online assignment, just maybe you have some, you try to reach the answer, and then it doesn't show the procedure, your handwriting, and that's the problem. So because of that reason, in this semester, just we should use just the same as the normal homework. You just write it. You can write it by hand or with your tablet, with your laptop, with your pen, anything, and then just upload the homework in the Blackboard, and then my grade A will grade that, right? So the reason is because the department want to get ABET. ABET is a standard quality, is a standard to check the qualification of the course, and then because of that reason we need some sample of the bunch of the homeworks, the real homeworks, not just the online assignment. So because of this reason, we don't use the Connect. So then, okay, so I just assign the homework, and then you can solve the homework, and then upload your solutions in the Blackboard, and then after some days my grader maybe grade that the homework, and also then I will post the solution, right? And since that's a 300 class, so I'm flexible. So if you wanna just extend some due for the homework, if you're busy, just let me know. If many of you just, if some of you just request for the maybe extension, so we can also extend due. So let's see. So it depends. So I assign the homework, and then maybe I do 1 week after I assign the homework, and then 1 week, 10 days. It depends. Yeah, does it make sense to you?
Yes, sir.
Yeah. And so
I got a question.
uh-huh.
So you said the 8th edition isn't required?
I'm saying it's not required to get the 8th edition if you already have the older one, or because 8th edition maybe it's a bit more expensive. If you get the other editions, that's fine. If you use the used one or rent, any edition is good. But I assign the homework from the 8 editions, and maybe but I take a picture and send those pages to the Blackboard to just solve the homework.
Okay.
Right? Yeah. But the materials for the textbook for all the editions, there are some slightly changed, but we don't focus on that. Right? So we're going to talk about the stress, actual loading, torsion, pure bending, the design of the beam, shear stress, principal stress under a given loading. We focus on them in some more circle, and if you have time, maybe we focus also on the columns. I'm not sure this topic, but yeah, this semester actually I increased the points for the homework and for the decrease for the exam. So always we use the 90 points, 90% for the exams, maybe 30, but this time, and 10% for the homework. But this time I just use the 30% for the homework because we are in these conditions and we are not just in-person classroom. So just I extend the point for the homework, so you have more time at home, just do the homework, and then instead just 70 points for the exams. Also, 5 extra credit in class assignments. What does that mean? It means, yeah, that's just extra credit. Just some extra credit is not required. So if just for live chat, maybe sometimes, maybe just for 15 or 20 minutes, I just give you a problem and then you can think about that and solve it and then upload it before ending the class, right? For example, maybe I give you 20 minutes and then you solve it, just look at the desktop and just solving and then upload it. It's just as an extra for some lectures, it's not for all the lectures. And then at the end of the semester, based on all of these assignments, just assume the extra credits just up to 5%. And again, it's just for the live chat, just for the live session. It's not a, and then I just open a spot in the Blackboard and then you upload it. And it depends. It depends maybe when I'm teaching about the same material or maybe the material for the previous lectures. It's just something like that. So yeah, it's just extra credit. It's not a maybe. So that's about grading.
Hey, are you gonna update the syllabus for the online class, by the way, instead of in person?
What does that mean?
Like, are you gonna be updating the syllabus as you go along throughout the course, if anything changes for the online or what? Or is it just in person?
For sure, this semester will not be in person. Yeah.
All right, man.
I think this syllabus would be the same by the end of the semester.
All right, thank you. Sorry.
Yeah, no, I think, yeah. So that's about the rest of that. It would be the just general things. I will, so yeah, there are some policy for cheating or something like that. The exam for the exam, maybe have no makeup exam, and exam would be closed, book closed, notes, but maybe I give you the formula or maybe you can bring some formula sheet. I will let you know about. There are some general things, and if you have any problem for disability, just contact the Disability Center. Yeah, student disability services, just contact them. And I think, yeah, one student has some question about that at the end of this lecture. Just talk to me. Yeah, I just got an email from one of the students. I will be available at the end of this lectures. And these are some, yeah, I think the syllabus is very simple. Do you have any question about this syllabus?
I have a question, Professor.
Uh-huh.
I just added your course this morning.
Mm-hmm.
How long until I would be added to the Blackboard?
I think it takes 24 hours,
Okay.
but yeah. But if you need the material, just send me an email. If at the end of the class, I will send you the material, the syllabus.
Sounds good.
Yeah, if you need it, just remind me at the end of the.
Okay. Well, thank you.
Okay. And the other thing, as I said, so the class is not required to come. I will not check the attendance since we don't have. I just recorded and just uploaded in the YouTube. So, question. No, for this class you don't need MATLAB, Excel, nothing. This class is very, very fundamental. You don't need any software. This class. Yeah, please mute your. I got some noises. Please mute you. So yeah, this class, statics, dynamics, mechanics of the material, there are very fundamental class courses, so we don't need any tools for these classes. The other things, yeah, I think, I talked about general things. So, and let me also upload the first handout in the Blackboard. And today I want to talk about a little bit about statics and the other things. Let me say something to you. In the in-person classes, I don't know you have a statics or dynamic with me before. Huh? For these type of classes, always I wrote everything on the Blackboard in the class, so then it takes time, right? Since I just upload my lecture notes and talk about that, so the purpose is to cover all the topics from in-person class to online class. That's a purpose, that's a goal, right? So then it doesn't matter how much time I spend, which means in an in-person class I spend 75 minutes, but in online chat maybe it's very shorter than, because we don't need to write everything. So I can just talk about the formula, talk about the problems. Maybe I wrote a little bit something on the black whiteboard, but then instead we have extra times. If you have any question, you can ask me during the class and after the class. So the purpose is I cover all the topics from the in-person to online. But so it doesn't matter if maybe for sure maybe the class is not exactly the 75 minutes, maybe less than 60, 45, 50. It depends to cover the standard material per lectures, right? Because I'm trying to cover not too much and not too short, right? I want to just cover the maybe all the pages that when I write in the Blackboard in the actual classes, right? Because if I want to cover lots of material just in live chat, so because I'm not writing, then maybe it's too heavy, right? So what I'm gonna divide the time to, so the purpose is to cover all the material in-person classes, right? So
I have a question.
Mhm.
Do you have office hours, or do we like make appointments with you for
Yeah.
questions?
For the office so I'm gonna say, so we may have some extra time, so then you can ask me at the end of the class if you are, but if the time of the class and the time after the class, the time of the after class doesn't work for you, just send me an email and then we can arrange any other times just for you.
Okay, thank you.
Right, just because unfortunately before the class I'm
You're
very
welcome.
yeah before the class I'm very busy. I have other classes, but I have time after the class. But if after the class doesn't work for you, just send me an email, then we can talk any other time. Resubmit or the photos of the, yeah, for the exam I will talk about later. I may just submit the files from the Blackboard and then you can, and for the exam you just make sure to turn on your videos, because we need to record the exam also. Just turn on the videos. I wanna just see your work, and just turn on your video. What's your YouTube? I wanna send you the link by link for the. I wanna send the YouTube channel to you, and also send link by link in the Blackboard. I will send you. And
I have a question.
mhm.
For the extra credit, it said like in class, extra credit, how is that gonna work?
For example,
It's
for
not.
15 or 20 minutes, just I show you a problem, and then you can solve it. It's open book, open note, and then upload it in the Blackboard. Just scan it and unload. Does it make sense to you?
So like during class, you're gonna show us a problem and then we upload it to Blackboard?
Just at the end of the class, just I show you very short problems, and then you can solve it and then upload it. It's just for in class. It's not for out of the class. It's not. And you need to upload in the Blackboard. Don't send me by email. It has some certain time.
Is this all on the syllabus? Are these instructions all like listed on your syllabus?
Yeah.
Okay, mint. Thanks.
Yeah. So, any other question?
Yeah. So since we're doing like this semester completely online, like, are you going to be easier on the grading, you think, or are you still going to be swinging hard on us?
It's, it's okay. Since the online, so if the performance of all the students would be changed, so for sure we have some curving, right? So yeah, since the system goes from the in-person to online, so if all the grading, everything would be changed, so I consider the care for whole class. But even for the online or in-person, so we cannot consider some bonus just for some certain student or some
Yeah, perfect.
Yeah, but we can curve based on we need adjust.
All right, thanks, man.
Yeah. So let me stop sharing, and also let me upload. I have it on a 2-page. I want to upload the 2-page in the Blackboard, and also I want to discuss. It's about the course documents. So let's go. It's about. I want to solve the one statics problem first, just as a review, and also we need this problem for in some lectures. We want to continue this problem for some parameters in the material base. So, but let's me first upload. It could be file. Let me lectures. So that's lectures. So
Dylan, can you stop texting during class, bro?
Sorry, say that again, please. Okay, guys, I upload the file.
Sorry, I think like Dylan was like smoking or something on camera. I don't know. He just had like a bong or something, so I don't know. I just figured I'd tell him to stop.
Dude, you're trolling,
Kinda
bro.
inappropriate.
Shut up.
Huh?
You're fucking trolling, bro. Just let us learn. Stop. No one was smoking a bong, bro. You were smoking like 15 minutes ago.
Jeez.
Okay, guys,
Sorry, Brendan.
please mute when I am. Okay.
Yeah, sorry, man.
Okay, just okay, guys, please, if you don't have okay, if you have question about the syllabus or something like that, just ask me. Otherwise, let me start a little bit about the lectures, and then if you have any other question, then you can ask me at the end of the class, right? Okay. Question? Okay. So let me share my screen. So okay, guys. So can you? Okay. I'll upload this file. Can you see this file?
Yeah, we can see it.
Okay, thank you.
Yeah.
Yeah. So let me say something here before, just when I start talking about the material, just if you have any question about the material, yeah, just first of all, so we have about 70, 80 students, just please mute during the lectures. Then if you have any question, just ask me during the lectures about that. And then if you have any other question, just ask me at the end of the lecture, right? So, you know, this class, actually the prerequisite is the statics. So, and we want to talk about the, in this class, we'll focus on the material, but let's see. Okay, yeah, when the students come to the class, yeah, that's a mute, but after that, the students can talk, yeah, just, yeah, so, okay, let me say so, but one thing is very important from this, is that in the statics, the purpose is to find the forces, right, moment, something like that, right? And, okay, ask me your question.
Yeah, I just wonder why like Brendan's such a fucking virgin. He's like getting pissed for no reason.
Yeah.
Like I'm just trying to learn just like him, and he's over here just fucking spazzing out because me and my boy Dylan are just, you know, hanging
I don't know
out.
if this is the time or place you want to be doing this, to be honest. I think we're all just kind of chilling. So
I know, but Brendan's just killing that vibe. Like we're having a good time asking prof questions.
you're the only one that's bothered, man.
Dude, Brendan spazzed out and swore. I just think that's a bit
Professor, you
inappropriate.
can click on his name and kick him if he becomes too much of a problem.
Please.
I'm on the class list, dude. I'm just saying Brendan's got an issue with me.
Okay,
And
guys,
the rest of
please.
us are too. I think we should all stop.
Okay, guys,
Yeah, thank you, Brendan.
just please mute. Just please.
Yeah, sorry. All right, I'll mute. Brendan is, you know, a virgin though. Let's be real.
Just please. Just please mute, guys. Okay.
Yeah.
Yeah, please, guys, just please don't talk and just please. Yeah, as I said in the statics, so as you know, we just find the forces and the moments, right? And the purpose is for the material. We want to use these forces and the moments, and then we want to later discuss about the stress and how to design the frame, how to design the element, right? So, but now the important things right now is just a little bit review the statics to see, for example, in some very simple problems like trusses. Trusses is the structures under the axial forces, right? And then just as a review, how can we find the forces in the elements? How can we find the reactions, right? And then later in the course, then we want to talk about how to design the structures. Then we back to these forces, and then use the forces to design the structures, right? So let's just now today just a little bit review these problems. So, you know, in the statics, so we already learned about the trusses, right? Truss is a type of the structures, is a type of the structures is under the axial forces, right? It's under the maybe tension or compression, right? Something like that. So for example, you have a rod is under tension or under the compression, right? It's just axial forces, right? So in the statics, we have truss, we have beam. Beam is under axial force, under the shear force, under maybe moment, right? But now we want to talk about the beam later, right? So now let's just talk about this problem. So that's a truss is under the two forces. These two forces, 2 kilopounds. The length is 20 feet. The height is, for example, this 9 feet. This is 9 feet. These are the supports. This is a hinge or pin support. This is the roller support, right? As you remember from the statics. And so the first of all, if you have this problem, the first things to find the reactions, right? So, you know, from the statics, the hinge support, we have two reactions, something like that. So let me write in the whiteboard, for example, you know, in the statics, we have something like that, right? This is a hinge support. We have two reactions, something like this. We have roller support, maybe something like this. We have only one reaction, right? These are the somethings from statics. Just if you don't remember, just please this week a little bit review the statics. We have fixed supports, maybe something like that. We have three reactions, right? Something like this, right? Then we have, for example, we call this one in X reactions, Y reactions. This is Y reaction, this is X, Y, and this is the rotational reaction. So all these things from the ME300, right? So in this problem, okay, we have something like this, right? This is a truss. We have the hinge or pin supports, two reactions, and roller supports, just one reaction, right? Like that. So, and then, okay, to find the reactions. So, you know, in the statics, we have three reactions. We need the three equilibrium equation, right? Summation of force in direction of X equals 0, summation of force in direction of Y equals 0, and summation of the moment at any just certain points, right? So let's just start the equation, summation of force in direction of X, right? Then look at this structure. We have AX, EX, AX plus EX equal, and there is no AX plus H. There is just these two forces, right? Equal to 0, right? There is nothing. The force in direction of Y, we have AY, and these two forces, right? These 2 kilopounds downward would be negative, right? So we assume the positive direction is upward, then these two forces downward, right? So, so then using this equation, we can find AY, right? The third, so now we find AY, but we need to find AX and EX. So we have just one equation, but two unknown. Then we need to use the third equation, take the moment. So we should take the moment. So let's take the moment about endpoint. So I picked the point A to take the moment. So does anybody can say why we can, why it would be better to take the moment about point A or E?
So we can cancel the AX and the AY?
Exactly. So it's a K means kilopounds, right? So that's kilopounds. So we take the moment about 0.8 and we can cancel AX, AY. If we take the moment about E, we can cancel EX. So the reason we take a moment A and E, because we wanna, if for example, we take the moment about point C or point D, for example, point D, then again, we have AX and EX contribute to take the moment. And then again, we have a more unknowns, right? So it would be better to pick the point to have a more reaction on that. And then the A would be the best one, right? Then we can AX and AY pass 0.8. So there is no moment from these two. And then we can easily find EX, right? So summation of the moment about point A equals 0. So let's do this. So then the first step is, as a statics, we should assume the positive direction. So for example, we assume counterclockwise as a positive, right? Summation of the moment about A is equal 0. Counterclockwise is positive. So EX times 18. So EX times this length is 18, this arm. Is it a clockwise moment or counterclockwise?
Counterclockwise.
Counterclockwise, right? Because it rotates like this, right? Counterclockwise, so it's a positive. This 2, this force times this arm, 2 times 12, is clockwise or counterclockwise?
Clockwise.
It's clockwise, therefore is negative, right? Because we assume counterclockwise is positive. Then this 2 times 24 would be again clockwise. So using this equation, we can find EX. So EX is 4 kilopounds, positive, so that direction. So since we find EX, then go to this equation. I just denote this equation as a start. AX plus 4 is 0. AX is negative 4, which means the assumptions that was wrong for AX. The AX would be that direction, right? So this is the approaches to solve the reactions. We use the equilibrium equations, right? We have 3 equilibrium equations, and we find the reactions. So, and then let me ask questions. If you remember from the statics, we have 2 methods to find the internal force for the members. Do you remember those approaches or those methods to find the forces from the elements?
You separate each member, right?
Yes, that's
was it method of sections?
Method of section is one approach. The other methods? Method of joints, right?
Penis rifle.
Guys, please, this is the last one, so just...
Can you just kick him out, because he's being so childish and disrespectful.
I think his name, what's his name?
Jim Warren.
Jim Warren.
Oh, we can just technically report him to Dean and be done with it.
Yeah, for sure. For sure. It's very disappointing. It's very disappointing for me. I don't know why. I cannot find him.
Somebody was recording the class, like you could like show it because
he's been recording the whole time. The professor has.
Yeah, that's good.
Yeah.
I don't think he's here anymore. So
I haven't found him. He left.
He might have changed
his
name or left.
Yeah, that's very disappointing. Yeah, let it's a Jim Warren, right?
Jim Warren, yeah.
Yeah, I wrote the name. I want to report him tonight to the administration.
I think he did leave because there was 79 participants and now there's just 78. So.
Yeah, I think he did too.
Yeah, sorry guys.
Also, it's been pleasantly quiet since he's left. So.
Hi, Ian.
Okay.
Hi, Terry.
Okay. So,
hi, Sydney.
Okay. So can we? Okay, ready?
Yes.
Okay.
Thank you very much.
Let me. Okay. So it's a method of section and method of joints, right? So to solve the trusses. So let me. Okay, since in this problem I want to review everything from the truss, so let me just use both approaches to find all the forces for the member, right? So let's first start the method of the sections, right? So guys, can you see my desktop?
Yeah, we can see.
Okay, thank you. So let's just make a sections from here, from A, B, A, D, and D. So then we have something like that, right? Do you agree with me?
Yes.
Okay. Let me check the chat. Okay, thank you. So, one thing, if you remember from the statics, once we do the method of sections or method of joins, one thing, first of all, first I want to show the forces, right? When we draw the free body diagram, something like this. So we have two choices. We can show the K means kilopounds. That K means kilopounds, right? So we can show the forces as a tension force or compression force, right? Tension force or compression force. And once I taught the statics, always I consider the forces as a tension. And then if the sign, once you find it, if the sign is positive, then okay, it's tension, which means the assumption is right. If the sign is negative, which means that's compression, right? That's my method to solve the problem. I consider always everything based on the tension. So, so now let's, okay, but it's up to you. You can consider as a positive compression as a and the tension, but that would be the tricky. Then you need to make sure if you assume the compression, then if the sign is positive, then that's a compression, right? If the negative, that was tension. But always I consider the internal force as a tension. Then at the end I adjust based on this, right? So okay, let's just make a section here. So that's a free body diagram on the right hand side. This is 2 cubes, kilopounds, kilopounds. And this is FBA, this tension, FDA, FD, right? So then let's look at the point D. If we take the moment at point D, FDA and FDE just pass point D, no moment, and then we can find, just you can easily find FBA, right? So let's start. So we have FBA, these 2 cubes, three forces. One more thing, look at these 2 kilopound, this force also pass point D, right? There is no moment for this force, right? So, okay. So we have just these 2 forces. So FBA times this arm 9 is clockwise or counterclockwise?
Clockwise.
Is counterclockwise, right? Right? It looks like this. Let me. Can you see me?
Yes.
It looks like this, right? It's maybe. It's counterclockwise, right? This look like this. This look like that, right? So that was positive. And then these 2 cubes at point C. How about this one? It would be clockwise or counterclockwise?
Clockwise.
It's clockwise. It's clockwise, right? It's just negative. So then solve this equation, FBA 2.67, positive means tension. So guys, the other things in the statics, I said, okay, for the truss, every time you should show is a tension or compression, maybe in the parentheses here, something like that. Let's mention tension. Then let's look at point A. If we take a moment about point A, FBA past point A, FDA past point A, then we have FDE, we are able to find FDE. But if you remember from the statics, in this situation, it would be better just write the components, right? Just in this, because FTE times this arm, right? And then we need this angle. It's very difficult. So, but if you have a component, it's much more easier to take the moment, right? So we have the component for this. So here is 9, 12. We have a slope of this line, right? 3, 4, 5, right? This is slope. So this angle could be equal to this angle. And these are the components. This would be FDE times cosine alpha, and cosine alpha would be 3 over 4 over 5, right? This 4 over 4 is cosine alpha. And this component would be FDE times sine alpha. And sine alpha is 3 over 5, right? So we have these two components. And now we can just take a moment from these components, right? About point A. Right? So does it make sense about the component? Do you remember component of the forces?
Yep.
Okay. So we have,
Professor,
sure, yeah.
did you find the moment about point D first because there was 2 forces coming off of it?
From this point?
Yes.
Yeah, I have this force, but it's difficult to take the moment about point A directly around this force. Then first I find the component of the force, and then we want to start to take the moment.
I meant on the first one you did.
Here?
Yeah, you found the moment about point D.
Point,
Is that because you eliminate 2 of them?
exactly, yeah.
Okay.
That's the reason I pick point D. Right? Does it make sense to you?
Yep, thank you.
Mm-hmm. And also I pick point A here because I want to eliminate these 2 forces, BA and DA, right?
Okay.
So, okay, and now we want to take the moment about point A. Now we have 4 forces, 2 cubes, 2 cubes, and these 2 components, 4 forces and 4 moments. So let's start. First, let's start from this one. FTE cosine alpha 4 over 5. So this component, we're going to take a moment about point A. Is it counterclockwise or clockwise?
Which one are you talking about?
This force, this X component.
Gay sucks horse cock.
Is clockwise, right? Is clockwise, right? Just 4 over 5 FTE times this arm. This arm is 9 feet, right? And then it's rotating like that, right? It's clockwise, right?
Yes.
So that's negative. How about this one? The Y component times this arm. It's clockwise, right? It will
Yep.
be, okay. How about this 2? This 2 times this arm, it's clockwise, right? It's clockwise. And this one 2 times 24, 12, and 12 is 24, it's clockwise, right? So if you solve this equation, FDE would be -5. So it's negative, which means compression, right? Does it make sense to you? How we get the 3 or 4? Okay, let's look at this. We have 9 here. This is 12, right? Then this slope, this would be 3, this would be 4, right? Right? So I just use a similar thing. This is 9, 12, 9 over 12 is 3 or 4. And then this one using a square plus b square, that's c square, right? 9 plus 16, 25, and then it would be 5, right? So I talk about the method of sections to find FBA and FDE. And for the rest of this problem, in next page, I want to use joint by joint to find the other forces, which means we can review the method of joint also. So before going to the next page, do you have, I think the next page would be much more easier. Do you have any question about these things?
Is there a reason why you chose to do method of sections for this? Like, why didn't you do method of joints for the whole thing?
It's up to you. You can use, since I want to read.
Cowboys in the showers at Ram Ranch on their knees wanting to suck cowboy cocks. Ram Ranch really rocks.
Sorry guys, can you mute?
I think Jim is back.
Yeah, he keeps coming in as different names.
Yeah, he has a different name.
I just want to say I'm sorry to you, Professor. Like, this is completely disrespectful.
Yeah, I wanna, yeah, just give me some time. I wanna follow up this. Sorry. Yeah.
It's not your
I
fault,
would
Professor.
recommend,
I wanna.
adding a password to the call just so random people can't join.
The problem for password, if he is in the system, access the password. If I.
Well, I don't know if he is in the system or not. It could be a good measure.
Yes, I wanna. Yeah, I make a password and I put it in the blackboard.
I know,
but
you
also he can change his name though. So.
I know.
I know if you can catch him the next time he gets on, that's why he keeps changing it. If you can catch him next time he gets on, you can force mute him, and I think that kicks him, and it kicks him from the class.
Yeah.
I'm gonna pull his IP next time he joins.
Sure.
Please.
Sure, yeah. Sorry guys, so let me finish the next slide. So, okay, let's go to the method of joint. Let's start from joint B. Let's start from joint B. So, okay. So we have, this is a free body of this joint, right? We have two kips, FBC. This is FBA, we already find it, right? 2.67, this is FBD. So now it's very, very easy, right? Just summation of force in direction of x0, summation of force in direction of y0. And then just solve these two equations and find the force, FBC and FBD, right? Does it make sense to you? Does it make sense, right?
Yes, it makes sense.
Mm-hmm.
Yeah.
Okay, so we find FBC and FBD. Now let's go to joint C, right? So we already find FBC, right, from joint B. So then we want to find FCD. Let's go to joint C, like that. This is FBC we find here, tension. This is FCD. So just we need one equation, summation of force in direction of y, for example. -2, 3/5. If 3/5 means sine, right? FCD times sine alpha. That like. So then FCD would be this value, right? That joint C. So let's go next joint, for example, joint E. Let's focus on that. Then we are able, so we already find FDE, so then we can find FEA, right? Let's go to joint E. Joint E. This is 5 is compression, we find before. This is FEA, and this 4 is reaction, right? EX. Summation of, so we need just FEA, just summation of force in direction of y0. 5 times sine alpha Sine is 3/5. And then FEA would be 3. Positive means tension, right? And finally, we can go to joint A. We have FBA, we have FEA, we have these two reactions, then we can find AD. So, but guys, so I use these arrangements. You can use method of section for all, method of joint for all, anything. I use because I want to cover everything. So the review. So this is AX, AY, FEA, FBA, and FAD, right? Summation of force x0. This is -4 plus 2.67 plus FAD 4/5, which means cosine alpha, right? Summation of force, FAD cosine alpha. So we find FAD 1.67 in tension, right? So bottom line is something like this. This is our truss. So the forces 2.67 keeps this tension. This force is tension. This force is compression. This force is tension, compression. This is compression. This is tension. AE, AD is tension, right? So, and guys, we need this example actually maybe for next week to continue this example to solve some other parameters, right? So before going to other things, so do you have any question about these problems? Because that was just a review for the statics. So
is this a problem out of the textbook?
I don't think so. No. I use from the other. It's not for the textbook. Just
okay.
Yeah, it's not.
Would this be chapter 1 of the textbook you
suggested? We want to start from chapter 1, right? We want to start from chapter 1, but before directly going to the material, I prefer to solve these statics problems because it's very, very important. We need, because later we have some problems, and first of all we need to statically solve the problem, find the forces, and then goes to find the other material parameters, right? So, but yeah, this could be after this one, we want to start about the concept of the esters, and then to find the esters, we need the forces. Because of this reason, I focus on this problem to find the forces, right?
Okay, thank you.
Okay, so guys, so just stay in the room and let me stop the recording, and this I want to discuss something. Let me first stop the recording.